Hello, my dear children. Welcome to the mathematics class. Today we are going to discuss application of derivatives. We are going to discuss the chapter application of derivatives. In this chapter, we are going to discuss the sums in the exercise 6.2. The sums in the exercise 6.2. We have already discussed the concepts of exercise 6.2 and also one question yesterday. Okay, my children. Now come to the page number 205. Page number 205. See the question number 2. Question number 2. Show that the function given by f of x is equal to e power 2x is strictly increasing on R. Okay, my children, understood this question, my children? Right. Now come to the solution part. Given function is f of x, that is equal to e power 2x. I wrote here given function f of x is equal to e power 2x. To show the given function is strictly increasing or strictly decreasing, if you get any question with these two words, either strictly increasing, either strictly decreasing, or increasing or decreasing, if you get any question with these questions, any one of these terms, decreasing or increasing or strictly decreasing or strictly increasing, okay my children, then immediately you have to find the derivative of the given function. Remember this point, my children. Right. Now we are going to differentiate with respect to x. We are going to find the derivative of this given function. For that we are differentiating with respect to x. Understood this sentence, my children? Right. What is the differential operator? Yes, d by dx is the differential operator. So we are writing the differential operator d by dx on both sides. Okay, my children, this implies d by dx of f of x is equal to d by dx of e power 2x. Understood this step, my children? Just we wrote the differential operator d by dx on both sides. Then you get this step. Understood this step, my children? Right. This implies see LHS part d by dx of f of x. What is the value of d by dx of f of x? Yes, f dash of x. It is denoted by f dash of x. The value of this part is denoted by f dash of x. Understood LHS, my children? Right. Is equal to, come to RHS, d by dx of e power 2x is there in RHS, d by dx of e power 2x. If you observe this function, it is in the form of d by dx of e power x. Okay, my children, just to assume 2x as x in your mind. Okay, my children, so it is in the form of d by dx of e power x. What is the formula for d by dx of e power x, my children? Yes, e power x only. So e power 2x, not don't write here x. You should write 2x only, because we assume this 2x as x in your mind. So we should write that 2x as it is. Okay, my children, don't confuse here. Into d by dx of 2x, because we have assumed this number, this part as x in our mind. So we have to differentiate again. Okay, my children, understood? Means here we use the chain rule. Okay, my children, because d by dx of f of x is equal to f dash of x. Okay, my children, and d by dx of e power x is equal to e power x formula, and also chain rule. By using these three results, we got this step. Understood this step, my children? Right. This implies we write LHS f dash of x as it is equal to, come to RHS, e power 2x into, we have to find the derivative of this function 2x. So in this function 2 is the numerical coefficient. You know that rule. We can write the numerical coefficient before the differential operator. So we are writing this 2. 2 is here numerical coefficient. So we are writing this 2 before the differential operator d by dx. So 2 into d by dx of, then what will be left there? X only. Understood this step, my children? Right. This implies we write LHS as it is f dash of x is equal to, come to RHS, in this RHS 2 is a numerical coefficient. In general, we write a term with a numerical coefficient at the beginning. So here 2 is a numerical coefficient. We write this numerical coefficient at the beginning of this term. Understood this part, my children? Right, into e power 2x into we are going to find the derivative of this function d by dx of x. What is the value of d by dx of x? 1. Understood this part, my children? Right, because d by dx of x is equal to 1. By using this formula, we wrote this part. Understood this step, my children? Right. This implies we write LHS f dash of x as t is equal to, in the RHS, what will you get after simplification? 2 e power 2x. Okay, my children. Now we have to check whether this number is a positive number or negative number. If it is a positive number, we say that it is strictly increasing, or we can say that it is an increasing function. If this value is less than 0, then we say that it is a decreasing function, or it is a strictly decreasing function. Okay, my children. Now come to this part. Because 2 less than e power x less than 2, this value always lies between 2 and 3 for all x belongs to R. Okay, my children. Then 2 into this number, automatically it is a positive number. Between 2 and 3 means it is a positive number. So 2 into some positive number, what will you get? Positive number or negative number? Yes, greater than 0. Positive number. So greater than. So finally this value is greater than 0 for all x belongs to R. Understood this statement, children? Right. This implies, what can you say about this function f? Therefore, f is strictly increasing on R. Understood, my children? Right. Now come to the question number 3. Question number 3. Show that the function given by f of x is equal to sin x is. There are two parts. See the 2 parts, my children. Strictly increasing in the open interval 0, pi by 2, and the second part B, strictly decreasing in the open interval pi by 2, pi. Understood this question, my children? In this interval, we have to show that the given function is strictly increasing, and in this second interval, we have to show that the given function is strictly decreasing. Understood this question, my children? Right. Please remember this point, my children. Whenever you are getting a question with the terms decreasing function, increasing function, strictly increasing function, strictly decreasing function, then immediately find the derivative of the given function without any doubt, without any question, without any confusion. Immediately find out the derivative of the given function. Okay, my children, keep this point in your mind. Okay, my children? Right. Now come to the solution part. What is the given function here? F of x. So f of x is equal to sin x. We have to find the derivative of this function. So we are differentiating with respect to x. Understood this step, my children? Right. Then what is the differential operator? Yes, d by dx. So this implies d by dx of f of x is equal to d by dx of sin x. We wrote here d by dx, the differential operator, d by dx on both sides. Then we got this step. Understood this step, my children? Right. This implies, come to the LHS. What is there? LHS d by dx of f of x. What is the value of d by dx of f of x? Yes, f dash of x. We denote this part by f dash of x. Understood LHS part, my children? Right. Is equal to, come to RHS. What is there? D by dx of sin x. It is a standard derivative, d by dx of sin x. Derivatives of some standard functions. In that list it is also there. Okay, my children, do you remember this one formula? D by dx of sin x. What is the value of d by dx of sin x? Cos x. Okay, my children, understood this step? By using these two results. What are the two results? D by dx of f of x is equal to f dash of x, and d by dx of sin x is equal to cos x. By using these two results, we wrote this step. Understood this step, my children? Right. We have found the derivative of the given function here. Okay, my children? Now come to the first part. What is the first part? We have to show that given function is strictly increasing in the open interval 0 comma pi by 2. Okay, my children, just I wrote here strictly increasing in the open interval 0 comma pi by 2. Now we are going to show that the given function is strictly increasing in this interval. To show that, to prove that given function is strictly increasing, or to prove that given function is strictly decreasing or decreasing in the given interval, please remember these steps, my children. We have to choose any number. We have to choose any number from this interval. Between these two numbers, we have to choose any number. Understood this point, my children? Right. So I have chosen x is equal to pi by 3. Pi by 3 lies between 0 comma pi by 2. Isn't it or not, my children? Yes, we have chosen a number in this interval. After choosing a number on the interval, we have to substitute that number in f dash of x. What is f dash of x here? Cos x, we have already found. So in this result, we have to substitute the number which was chosen by us. Okay, my children. So we have chosen x is equal to pi by 3. We have to substitute x is equal to pi by 3 in this f dash of x is equal to cos x. Then we get f dash of pi by 3 is equal to cos pi by 3. Understood this step, my children? Right. That is equal to, what is the value of cos pi by 3? Yes, 1 by 2. Is this number great positive number or negative number, my dear children? Yes, it is a positive number. Means it is greater than 0. So we got here f dash of x is greater than 0. Understood the point, my dear children? Right. Therefore, we can say that f is strictly increasing in the open interval 0 comma pi by 2. Understood these steps, my dear children? Right. Now come to the second part of the question. That is, we have to show that given function is strictly decreasing in the open interval pi by 2 comma pi. Whatever the steps we followed in the case of showing the given function is strictly increasing, we follow the same steps here also. What is the first step? We have to choose a number from this interval. Within the interval between these two numbers, we have to choose any number. I have chosen x is equal to 5 pi by 6. This angle lies in the interval pi by 2 comma pi. Between these two angles, this angle lies. Isn't it or not, my children? Right. Now we substitute this number, whatever we have chosen. We have to substitute that number in f dash of x. What is f dash of x here? Cos x. We have already found it. Okay, my children. Then we get f dash of 5 pi by 6 is equal to cos 5 pi by 6. Understood this step, my children? Just we have substituted x is equal to 5 pi by 6 in f dash of x. Then we get this step. Okay, my children? Right. This implies we write LHS as it is f dash of 5 pi by 6 is equal to cos of, we can write 5 pi by 6 as pi minus pi by 6. Isn't it or not, my children? Yes, we can write it. Understood this step, my children? Right. This implies we write LHS as it is f dash of 5 pi by 6 is equal to cos of pi minus theta. What will you get? Minus cos theta. This angle lies in the second quadrant. So we get negative because cos is negative in the second quadrant. So minus cos pi by 6. Understood this step, my children? Right. This implies f dash of 5 pi by 6 is equal to minus, what is the value of cos pi by 6? Yes, root 3 by 2. So finally we got minus root 3 by 2. Is it positive number or negative number, my children? Yes, negative number, because minus sign is there. So it is a negative number, means it is less than 0. So f dash of 5 pi by 6 is less than 0. We got here f dash of x value less than 0. Therefore we can say that f is strictly decreasing in the open interval pi by 2 comma pi. Understood, my children? Right. Now come to the question number 4. Question number 4. Find the intervals in which the function f given by f of x is equal to 2x cube minus 3x is, first part, strictly increasing, and second part, strictly decreasing. Understood this question, my dear children? In the previous questions, they have given the intervals and we have checked, we have verified whether the given functions are increasing or decreasing in that given intervals. But in the reverse order, here we had to find the intervals. Here they did not give intervals. We have to find the intervals in which the given function is strictly increasing and strictly decreasing. Understood this question, my dear children? Right. Now come to the solution part. First we write given function. What is the given function here? F of x is equal to 2x cube minus 3x. Okay, my dear children, just we write the given function. What I said, if you get any question with the terms strictly decreasing, strictly increasing, decreasing or increasing, immediately find the derivative of the given function. So we are going to find the derivative of this given function. For that we are differentiating with respect to x. What is the differential operator here, my dear children? Yes, d by dx. So I wrote the differential operator d by dx on both sides. This implies d by dx of f of x is equal to d by dx of 2x cube minus 3x. Understood this step, my children? Right. This implies, see LHS, what is there? D by dx of f of x. What is the value of d by dx of f of x? Yes, f dash of x. Understood LHS, my children? Right. Now come to RHS. D by dx of 2x cube minus 3x. If you observe this function, it is defined as the sum of two terms. So to find the derivative of this function, we can find the derivative of each and every term separately and we can add them. Automatically we get the derivative of this entire function. Okay, my children? Just like a distributive property. So d by dx of 2x cube minus d by dx of 3x. Understood this step, my children? Because d by dx of f of x is equal to f dash of x. By using this result, we wrote this step. Understood this step, my children? Right. This implies I wrote LHS as it is, that is f dash of x is equal to. Now come to RHS. First let us find the derivative of this first term. In this first term, 2 is the numerical coefficient. So we write numerical coefficient before the differential operator d by dx. So we wrote it. So 2 into d by dx of, then what will be left here? X cube. Understood this first term, my children? Right. Minus. Come to the second term. What is there? D by dx of 3x is there. In this term also, there is a numerical coefficient, that is 3. So we write numerical coefficient 3 before the differential operator d by dx. Understood this part, my children? Then what will be left here? X only. So minus 3 into d by dx of x. Understood this second term, my children? Right. This implies we write LHS as it is, f dash of x is equal to 2 into, now come to the part, d by dx of x power x cube. What is a suitable formula to find the derivative of this function? Yes, d by dx of x power n is a suitable formula to find the derivative of this function. It is in the form of d by dx of x power n. Okay, my children, understood? Right. Then what is the derivative of this function? 3x square. By using that formula, we get here 3x square. Understood this part, my children? How we got 3x square? Right. Minus 3 into d by dx of x. What is the value of d by dx of x? Right. 1 only. These are derivative formulas, depend upon the derivative formulas. Because d by dx of x power n is equal to n into x power n minus 1 and d by dx of x is equal to 1. By using these two formulae, we get this step. Understood this step, my children? Right. Now we simplify the terms. Then this implies f dash of x is equal to, what will you get here? 2 into 3x square, 6x square. Understood this first term, my children? Minus 3 into 1. What will you get? 3 into 1? 3. Understood this step, my children? Right. So here we got the derivative of the given function, that is 6x square minus 3. Understood, my children? This is the first step. After that, we have to find the intervals. To find the intervals, we have to follow these steps. Remember these steps, my dear children. Listen carefully. Okay, my dear children. Right. Now come to this part, my dear children. This is important part. Finding critical points or stationary points or turning points. After finding the derivative of the given function, this part is important for finding the intervals in which the given function is in decreasing or increasing. Okay, my dear children. Right. Listen these steps carefully, my dear children. First of all, we have to write this equation. F dash of x is equal to 0 for finding the critical points or stationary points or turning points. These are nothing but the solutions of this given this equation. F dash of x is equal to 0. Okay, my children. Right. This implies what is f dash of x here? What you got here? 6x square minus 3 is equal to 0. Understood this step, my children? Just we substituted f dash of x in LHS. This implies 6x square is equal to 3. Okay, my children. Right. Understood this step, my children? Right. This implies x square is equal to 3 by 6. We send this 6 to the RHS, it becomes by 6. Understood this step, my children? Right. This implies x square is equal to 1 by 2. After solving, after simplifying this fraction, we get 1 by 2. Understood this RHS, my children? Right. This implies x is equal to plus or minus 1 by root 2. Okay, my children, these are the values of x. Now we write this number in the decimal form. Okay, my children, this implies x is equal to plus or minus 0.7071. This is the value of 1 by root 2. Understood this point, my children? Right. So we got here two values for x. What are the two values? One is minus 0.7071 and another one is plus 0.7071. Two values we got for x. These two values are said to be critical points or stationary points or turning points. Okay, my children, remember these points, my children. After finding the values of x here, we have to label these values on the number line. Let us draw the number line here. On this number line, 0, here 1, here 2, left side minus 1, minus 2 and so on. What is this number? Minus 0.7071. It lies between minus 1 and 0. I marked here between minus 1 and 0. Minus 0.7071. Plus 0.7071 lies between 0 and 1. Between these two numbers, that number lies. So I marked here approximately. So if you observe this number line, these two numbers are dividing the entire line into three distinct intervals. Namely minus infinity to minus 0.7071, this interval, this open interval. Next to minus 0.7071 comma 0.7071, this interval, and third interval 0.7071 comma infinity. Understood these three intervals, my dear children? These three are distinct intervals. The number line, real number line, is divided by these critical points or stationary points or turning points into three distinct intervals. Understood, my dear children? Now we got three intervals. In these three intervals, what should we do? We have to choose any number. And we have to substitute that number in f dash of x. After that, do you remember the steps, my dear children? We have to substitute that number in f dash of x. If f dash of x is greater than 0, what should we say? It is increasing in that particular interval. If f dash of x is less than 0, then we say that the function is decreasing in that particular interval. Okay, my dear children? Understood this point? Right. So we got three distinct intervals. Okay, my dear children? In each and every interval, let us find the behavior of the function, whether it is an increasing function or it is a decreasing function. Okay, my dear children. Right, see here, verifying in the interval minus infinity comma minus 0.7071. In this open interval we are verifying that. So let us take any value between this interval. In this interval we can choose any number for as per our convenient. So I have chosen x is equal to -1. This number belongs to this open interval. Understood this step, my children? Right. After selecting a number in this interval, we have to substitute that number in f dash of x. So put x is equal to -1 in f dash of x is equal to 6x square minus 3. Then we get f dash of -1 is equal to 6 into -1 whole square minus 3. Understood this step, my children? After substituting x is equal to -1 in f dash of x, we get this step. Understood this step, my children? Right. Now we simplify this one. That is equal to 6 into -1 whole square. What is the value of -1 whole square? 1. Understood this first term, my children? Right. Minus, we write the second term as it is. Understood this step, my children? Right. That is equal to, what is the value of first term? 6 into 1, 6. Minus, we are writing second term 3 as it is. Understood this step, my children? Right. This implies that is equal to, what is the value of 6 minus 3? 3. Greater than 0. It is a positive number. Is it a positive number or negative number, my dear children? Yes, it is a positive number. Means it is greater than 0. So we got here f dash of -1 is greater than 0. Then what will you say? Then we can say that f is increasing in this interval minus infinity comma minus 0.7071. In this interval f is increasing. Understood this point, my children? Right. Now we verify the behavior of the function in the next second interval, that is open interval minus 0.7071 comma 0.7071. We follow the same steps here also to verify to know the behavior of the given function, whether it is a decreasing or increasing function. Okay, my children? So let us choose any number from this interval. I have chosen x is equal to 0. 0 belongs to open interval minus 0 comma 7071 comma 0.7071. Isn't it or not, my children? Right. Understood this step, my children? Right. Now we put x is equal to 0 in f dash of x. As we followed the steps here, we follow the same steps here also. Okay, my children? Right. So f dash of x is equal to 6x square minus 3. Then we get f dash of 0 is equal to 6 into 0 whole square minus 3. Understood this step, my children? Right. That is equal to, what is the value of first term? 0. Minus, we wrote second term 3 as it is. That is equal to, what is the value of 0 minus 3? Minus 3. Is it a positive number or negative number, my children? Yes, it is a negative number. Minus sign is there. So it is a negative number, means less than 0. So f dash of 0 is less than 0. We got this statement. Understood this step, my children? Right. Then what will you say about f? The behavior of f? F is decreasing in this open interval minus 0.7071 comma 0.7071. Understood, my children? Right. Now come to the third interval. We verify in the interval 0.7071 comma infinity. In this interval we verify the behavior of the function, whether it is a decreasing function or increasing function. For that we are choosing a number from this interval. Between the two numbers we have to choose a number. I assumed I have chosen x is equal to 1. This number belongs to open interval 0.7071 comma infinity. Isn't it or not, my children? Right. Understood this step, my children? Right. After that we have to substitute. We have to put x is equal to 1 in f dash of x is equal to 6x square minus 3. We get f dash of 1 is equal to 6 into 1 whole square minus 3. Understood this statement, children? We are substituting x is equal to 1 in f dash of x. Then we get to this step. Understood this statement, children? Right. This implies f dash of 1 is equal to 6 minus 3. Understood this statement, children? Right. This implies f dash of 1 is equal to, what will you get? 6 minus 3? 3. Is it a positive number or negative number, my children? Yes, it is a positive number, means greater than 0. We got here f dash of 1 is greater than 0. Then what will you say about f? F is increasing in the interval, open interval 0, 7071, infinity. Understood, my children? In this exercise, there are only two types of sums are there. First type of sums is they will give the function and also interval. Just we have to verify whether the given function is increasing or decreasing in that particular interval. And the second type of function, second type of questions are, we have to find the intervals in which the given function is increasing or decreasing function. Okay, my children, will you try the remaining questions in this exercise, my children? Right.